Imagine being strapped to the top of a towering machine, a modern monolith packing over 8 million pounds of thrust. The countdown reaches 0. The ground beneath you shatters with a deafening roar. The sky cracks open. The familiar blue fades into a deep, absolute black. And suddenly, you are falling upward into the void. For over 50 years, the script of human spaceflight has ended predictably in low Earth orbit. The International Space Station, while an absolute marvel of engineering and international cooperation, is essentially our front porch. It is safe, it is relatively close. If a catastrophic emergency occurs, a crew can theoretically jump into an escape capsule and be back on solid ground in a matter of hours. But what happens when you decide to leave the porch? What happens when you cross the threshold where a quick rescue is no longer governed by physics, but rendered absolutely impossible? 4 humans are about to find out. We have not ventured into the deep dark since 1972. When Apollo 17 Commander Gene Cernan lifted his boot from the powdery lunar regolith, leaving the final footprint in the dust, he promised humanity would return. He likely didn't think it would take over half a century to make good on that promise. Entire generations have been born, lived, and died without ever witnessing a human being leave the cradle of Earth's immediate gravitational embrace. In the decades that followed Apollo, we traded the wild, unforgiving frontier of the moon for the repetitive, albeit highly necessary, loops around our own planet. We built the space shuttle. We constructed orbiting laboratories. We learned how to live in microgravity, how to grow plants without soil, how to recycle our own sweat and breath, and how to maintain a permanent human presence in the sky. Yet, the deep ocean of space, the hundreds of thousands of miles of terrifying emptiness between us and our nearest celestial neighbor, has remained devoid of human voices. The hardware that once took us there now sits quietly in museums, gathering dust behind velvet ropes. Now, that decades-long silence is about to be shattered. Enter Artemis II. To the casual observer watching the news, this mission might look like a simple repeat of history, a modern echo of Apollo 8, a quick lap around the moon and a safe return home. But Artemis II is not landing. It is not dropping a flag into the gray soil. Instead, it is executing something fundamentally more dangerous and arguably far more crucial for our survival as a spacefaring species. Artemis II is the ultimate stress test of human engineering, modern engineering, and deep space survivability. Sitting atop the Space Launch System, the most powerful rocket ever successfully flown, the 4 astronauts will be thrust outward at speeds exceeding 24,000 miles per hour. Once the upper stage of the rocket fires its engines to break them out of Earth orbit, initiating what orbital mechanics call a translunar injection, the safety net is permanently severed. The crew will be committed to a trajectory that flings them hundreds of thousands of miles away. This isn't just a sightseeing trip. It is a calculated exposure to an environment that actively wants to destroy everything inside that pressurized cabin. This will be the farthest humans have traveled since the Apollo era, and they will be doing it in a ship that has never carried a single living soul before. As the Earth shrinks from a massive, dominant sphere filling the window to a small, fragile blue marble suspended in the dark, the physical reality of their isolation will set in. Inside the Orion capsule, the 4 astronauts will experience a profound and violent shift in their environment. Beyond the protective magnetic bubble of Earth, the magnetosphere, space changes its character. It is no longer just empty. It becomes highly energetic and deeply hostile. Here, the crew will face the invisible, relentless bombardment of deep space radiation. They will fly directly through the Van Allen radiation belts, zones of trapped, highly charged particles that can scramble computers and alter human DNA. Beyond that, they face galactic cosmic rays, subatomic particles traveling at nearly the speed of light from exploding stars across the universe. These particles will literally tear through the metallic hull of the ship and pass through the astronauts' bodies. In deep space, when an astronaut closes their eyes to sleep, they don't just see the comforting blackness of a dark room. They see sudden, vivid flashes of light, sphenes, caused by high-energy cosmic rays striking their retinas and optic nerves. It is a constant, physical, and unnerving reminder that they are swimming in a radioactive sea, far beyond the shores of home. To survive a sudden solar flare, an unpredictable eruption of deadly radiation from the sun, the crew cannot simply outrun it. They will have to build a makeshift storm shelter using thick supply bags, equipment, and their own seats in the lower bay of the capsule, huddling together in the cramped, dark space while the invisible storm rages outside the hull. But radiation is only one of the phantom terrors of the deep dark. There is also the sheer, unforgiving nature of the distance. If a critical medical emergency occurs on the International Space Station, or if a piece of space debris punctures a vital cooling loop, the crew has options. On Artemis II, if the life support system stutters, if a fire breaks out behind a panel, or if an astronaut's heart suddenly gives out halfway to the moon, there is no abort button that brings them straight down. The unyielding laws of orbital mechanics dictate the ride. They must swing around the moon, using its gravity to slingshot them back toward Earth. A crisis on day 3 means they must figure out how to survive until day 10 to make it home. Every breath of oxygen they take, every drop of recycled water they drink, and every single line of code keeping the thermal systems running becomes a lifeline stretched thinner than it has been in over 50 years. The Orion capsule becomes their entire universe, a tiny bubble of air, light, and warmth, plunging through a vacuum that rests near absolute zero. Yet, perhaps the most profound challenge these 4 humans will face will not be physical or mechanical, but deeply psychological. The human brain evolved to understand terrestrial distances, the miles across a valley, the horizon over an ocean, the curve of a continent from an airplane window. It was absolutely not built to comprehend a void so vast that light itself takes seconds to cross it. As the astronauts drift further into the inky blackness, the invisible radio signals tying them to mission control will begin to stretch and lag. A simple question asked into a headset will be met with silence, followed by the agonizing wait for the signal to reach the antennas on Earth and for the reply to travel back across the void. That delay, just a few seconds during Artemis II, but a haunting precursor to the 20-minute delays of a future Mars mission, is the auditory proof of their utter isolation. They will look out the small window of the spacecraft and see the moon growing monstrously large. A desolate, battered landscape of gray craters silently passing below them. And when they turn their gaze back toward where they came from, they will experience the overview effect in its most extreme and humbling form. They will not see the distinct continents, cities, or weather patterns visible from low Earth orbit. They will see the entirety of human history, everyone they have ever loved, every war ever fought, every tragedy endured, and every triumph ever achieved, all contained on a pale, glowing sphere that they can completely cover with an outstretched thumb. The psychological weight of that visual isolation, of being so completely unmoored from the home world and suspended in the infinite, is something only 24 people in the entire history of our species have ever known. These 4 astronauts will be the very first to feel it in the 21st century. As their trajectory carries them around the far side of the moon, there will be a chilling period of absolute, unbroken radio silence. The staggering mass of the moon will physically block all communication signals with Earth. For roughly an hour, these 4 humans will be the most isolated living creatures in the known universe. They will be entirely cut off from the voices of their families, the guidance of engineers in Houston, and the collective heartbeat of humanity. Floating in the eternal night of the lunar shadow, they will have to rely solely on their years of grueling training, the hum of their ship's life support systems, and the trust they have in each other. It is in this profound, heavy silence that the true weight of the Artemis mission will be felt. They are not merely testing rocket engines, navigation software, and carbon dioxide scrubbers. They are testing the human spirit's ability to endure the terrifying infinite. Eventually, the gravity of the moon will whip them back toward the blue marble. But coming home is just as violently dangerous as leaving. The return from deep space is fundamentally different from a routine drop out of low Earth orbit. Because they are returning from so far away, Orion capsule will slam into the Earth's atmosphere at a staggering 25,000 miles per hour. The heat shield at the base of the spacecraft will face temperatures approaching 5,000 degrees Fahrenheit, nearly half as hot as the surface of the sun itself. The air in front of the capsule will not just compress, it will ignite into a blistering, roaring plasma, completely enveloping the ship and temporarily severing all communications once again. The astronauts will be violently thrown against their straps, crushed into their seats by intense G-forces as the ship rapidly decelerates. To survive this extreme re-entry, Orion will execute a maneuver never before used by a crewed spacecraft, a skip re-entry. Like a stone skipping across the surface of a pond, the capsule will dip into the upper atmosphere, bleed off immense speed and heat, briefly pop back out into space to cool down, and then dive back in for the final descent. The margins for error are terrifyingly thin. If the angle of re-entry is even slightly too steep, the heat shield will fail and the ship will burn up in a streak of light. If the angle is too shallow, they will bounce off the atmosphere entirely, lost to the solar system forever. But if the mathematics hold true, if the engineering survives the trial by fire, the massive orange and white parachutes will deploy in the sky, and the capsule will splash down heavily into the waters of the Pacific Ocean. When it does, it will bring a brand new era of deep space exploration home with it. Because Artemis II is not the finale of a story. It is merely the prologue. This dangerous, audacious swing around the moon is the necessary, unavoidable proving ground for everything that humanity hopes to accomplish next. We are returning to the moon not to relive the past, but to learn how to live in the future. We are going back to build a permanent orbital gateway, to extract frozen water from the permanently shadowed craters of the lunar South Pole, and to rigorously test the technologies that will one day keep human beings alive for months or years at a time. The unforgiving deep space environment that the Artemis II crew will pioneer is the exact same environment we must ultimately conquer if we ever hope to reach Mars. The crushing psychological isolation, the constant threat of cosmic radiation, the terrifying lag in communication, and the reliance on closed-loop life support. These are the modern dragons lurking on the edges of our star charts. The crew of Artemis II is sailing directly into their waters, proving that we can not only survive out there, but thrive. For 50 long years, we have stood on the ground, looked up at the silver disk of the moon, and remembered what we used to be capable of. When the Orion spacecraft returns from the dark, smelling of ozone and scorched metal, we will no longer be looking back at history. We will be looking directly at the future. The training wheels are finally coming off. We are, at long last, truly leaving home.